new video. Okay, so students, today I'm going to solve quant-based questions, or rather the questions which are generally coming in quantitative analysis section of entrances such as CAT, SAT, GMAT, ACT, GRE, etc. Okay, and trust me, you will realize that it is really not that difficult to solve these kind of questions. Okay, but you need to understand these kind of questions very clearly. So let's start talking about the first question. The first question says that find the number of 4-digit number which is divisible by 7 and whose sum of digits is divisible by 3. Now the question, students, over here, if you look at this particular statement, that is sum of digits, that is actually a bit just given there. It's basically not even needed. They could have just said which is divisible by 3. The reason being, the divisibility test of 3 is nothing but that sum of the digits of all the numbers have to be divisible by 3. Okay, students, for these two questions, you need to have very strong understanding of divisibility tricks. Okay, so if you don't know these tricks of the divisibility test of 3, 7, 11, 8, 9, etc., then I have made a video of the same, and the link of that will be pushed up on top as well as in the description. So please do go ahead and check that out. But watch those videos only after watching this particular video. Also, students, I would like to tell you that at the end of this video, I will push up a question which will be either of these two questions form. Okay, so please go ahead and write the answer of that particular question in the comment section. Okay, so let's talk about this particular question now. Over here, we need to find a number of 4-digit numbers. So we know that the lowest 4-digit number is what, 1000, and the biggest 4-digit number is 9999. And we need to check those numbers who are divisible by 7 as well as 3, and you need to understand, and you need to figure out how many such numbers are available. So first things first, we will check for the divisibility test of 3 because that is much easier. Okay, so we see 1000 is not divisible by 3. We see 1001 is again not divisible by 3. Now the next number which is divisible by 3 is 1002 or 1002. But what happens is, for the divisibility test of 7, it says that the last number has to get doubled and it will get subtracted from the rest of the number. So here the double of 2 is what, 4, and you subtract 4 from 100, you get 96, and we know that 96 is really not divisible by 7. So here your 1002, even though it is divisible by 3, we cannot take it into consideration. Okay, now let's see, 103 is not divisible by 3. 104 is divisible. So let's say 1004 when you 1004 when you check for divisibility test of 7. So the last digit is 4, so double it gets you 8. So you subtract 8 from 100, you get 92. So that is again not divisible by 7. So we'll check the other numbers now. 1005 is, or rather 1004 was not divisible by 3. I'm so sorry. So we should check for 1005. Now 1005 also, when you double the 5 and you subtract it, you get 90. So that is not divisible by 7. So now doing so on and so forth, you will realize that 1008 is a number which is divisible by 3 as well as 7. Let's check. 8 when doubled gets you 16. Okay, and when you subtract 100 minus 16, you get 84, and that is divisible by 7. So 1008 is divisible by 7. Okay, as well as 1 plus 0 plus 0 plus 8 gets you 9, which is again divisible by 3. So we know that the first number will be 1008. Okay, now let's check for the last number in the similar manner. You will realize that the last number which you're getting is 9996. Okay, so this became your first term, this became your last term, and you need to find the value of n. But using the formula of Tn, which is a plus n minus 1 into d, you need to find out what is your d, and your d will always be the LCM of 3 and 7, that is nothing but 21. So now 9996 is equals to 1008 plus n minus 1 into 21. When you subtract 9996 from 1008, what you get is 8988. Okay, and that is equals to n minus 1 into 21. When you divide 8988 by 21, your n minus 1 you get as nothing but 428. Therefore, I can say n is equals to 429. Meaning, you will have 429 such numbers which are 4-digit and which are divisible by 7 as well as 3. Okay, so students, now you